Hi there, and welcome to Probability Part 3. We're looking at two kinds of events that you will have been familiar with at GCSE. Mutually exclusive events, those ones which, if one happens, the other can't happen. And independent events, things like rolling two dice and the chance of getting a double six, where you multiply the probabilities. But there's another kind of event, isn't there? There's ones which can happen both at the same time, but they're not independent of each other. So, for example, I might go out on a day when it rains without my coat, but it's probably more likely that I take my coat with me if the weather's looking a bit dodgy. So those things are going to affect each other. So it's not going to be unlikely to be independent events, dodgy weather and me taking my coat. So how do we show, or how can we find out if two events are independent? And that's the biggest thing that we're going to learn today. And it's quite a simple thing, but quite powerful too. So without any more waiting on, let's get on with it. Right, so just by looking at these Venn diagrams, we can actually come up with a rule or two that's useful. For mutually exclusive, the thing I want us to think about is that the probability of A or B, so the probability of A happening or B happening, is definitely going to be the probability of A plus the probability of B happening. That's not going to be true for A and B here, because the probability of all of A and B, they overlap, so you'd be double counting a couple of bits if you did that. So how do we write that using notation? Well, A or B would be A union B, wouldn't it? So you can also think of it as that. Now if we come over to A and B, we come to what I was just talking about before. If we want the probability of A and B, that's going to be the probability of A times the probability of B. We could also write that as A intersection B, couldn't we? Being the probability of A multiplied by the probability of B. Now we can write down something for the probability of A or B, but that's not for today. That'll be for year 2 probability, so don't worry about that right now. Okay, so now we're going to use some of this in a few examples, and then we'll have a few questions for you to have a go at. Right, here's our first example then. So write this down, have a think about it, start by drawing a Venn diagram and see where that takes you. So there's only 3 parts on a Venn diagram for two mutually exclusive events, so all 3 of those are taken account of here. So let's draw it first, and then it's easier to see what it is that's going on. So you've got A, you've got B, and it says A is 0.2 and B is 0.4. So as everything's got to add up to 1, 4 and 2 is 6, so this must also be 0.4 there. So the probability of A or B is going to be 0.2 plus 0.4, which is 0.6. Probability of A but not B, well, if it's A, it's not going to be B anyway, it's just going to be the probability of A. And the probability that it's neither A nor B is going to be what's outside of the loops, so it's 0.4. And that's that one. Here comes another. This one shouldn't take long. By the time you finish writing down the question, hopefully you've worked out what you've got to do. Just for the sake of putting a Venn diagram in so that we see everything, it may seem a bit pointless in one question as brief as this, but still it is important, so that it'll make other ones easy to do. That's what we want. That's what you get if it's independent if you multiply them. So the probability of A and B which means intersection, because it's in both of them, is going to be a third multiplied by a fifth, which is 1/15. If you did it as a decimal, fair enough, but trickier. And one more example coming up. Okay, slightly wonkily drawn, so sorry about that, but pause the video and have a go at this. This is kind of where the whole thing's been heading. So the probability that a student chosen at random watches B or C or both. So that is going to be that one, that one, that one, because that's all B. This is C, and both is that 10 in there, isn't it? So what have we got? We've got 4 plus 5 is 9, 19, 26 out of 29, 30. So 26 out of 30. And you can simplify that if you like to 13 over 15. The business end part is part B. Determine whether watching A and B are statistically independent. So first of all, we need what's the probability of A, and that's going to be 3 and 4 makes 7 out of 30. What's the probability of B? Well, that's going to be a bit more popular, isn't it? 10, 15, 19 out of 30 watch B. Now if we multiply these two together and we get 4 out of 30, we're in business. So 7 out of 30 times 19 out of 30 is going to be equal to, doesn't look like 4 out of 30, but let's whack it in the calculator anyway and see. 7 out of 30 times 19 out of 30 equals 133 over 900, and we could turn that into a decimal, couldn't we? Equals 0.1477 recurring, whereas 4 over 30 equals, well, we know it's a different fraction anyway, 2/15, which is 0.13 recurring. So 133 over 900 does not equal 2/15, therefore not independent. Okay, we've got a few questions that we're going to do now, and then that'll be that. Right, we've got 3 exam questions for you coming up. Here's the first one. So, writing down the value. Well, they're all going to add up to 1, aren't they? So 0.4 plus 0.3 is 0.7, so that makes 0.75. So x is going to be 1, take the 0.75, which is 0.25. Determine whether the events like pasta and like pizza are independent. They're unlikely to be, aren't they? I like both, certainly. Anyway, so if that's 0.25, pasta is 0.65, and then pizza is going to be 0.25 plus 0.3 is 0.55. So the probability of A and B is going to be 0.65 multiplied by 0.55, which is 0.3575, which is not 0.25, so therefore they are not independent. Here's your next one. When you've written a question, get into it with a Venn diagram first. Okay, so the Venn diagram is going to have W and X, and they are intercepting. Neither W nor X is going to be the bit outside, so that'll be 0.3. We know that W is 0.25, is 0.5 and W without X is 0.25. So that's W without X. If W is adding up to 0.5, this must also be 0.25. Now to work out whether or not they're independent, we need to do the probability of W multiplied by the probability of X. Well, that means we need to fill this in. Well, that's 0.5 plus 0.3 makes 0.8, so that must be 0.2. So the probability of W is 0.5. The probability of X is 0.2 plus 0.25 is 0.45. Multiplying those together, and it needs to be 0.25 if they're going to be independent, and it doesn't look like it is. That's getting me 9/40ths, or 0.225. That is not 0.25, which is the actual probability of them both happening together. Therefore, again, it's not independent. Right then, final question, and we're done for the week. Pause the video, have a good go at it. Right, so we know that the probability of someone taking part in the archery or the raffle is 0.6. So the archery is 0.2. The raffle, but not the fun run, is 0.25. But those two together make the raffle. That should all be adding up to make the 0.6 that they're telling us. Well, that's 0.45. 0.45 plus 0.15 is 0.6, so X must be 0.15. Now that we know that, we've got everything here apart from Y, and as they're all going to be adding up to 1, all we have to do is add them up, which gets us to 0.6 there, plus 0.1 is 0.7, so we've just got 0.3 left over to make up to 1, so Y is 0.3. Now show that R and F are not independent. That means when we multiply them together we shouldn't get 0.15. So we've got probability of R times the probability of Y should not be equaling 0.15. So let's do that. Probability of R is 0.15. No, it's not. Probability of R is 0.4, isn't it? Probability of Y is 0.3 plus 1.5 is 0.45. Multiply those together. Should have given you 0.18, and that is not 0.15. And therefore we've shown that they're not independent. And that's all for now, so see you next time everyone. Bye bye.